Good morning, everybody. Good morning, and welcome to Math in the Morning. What's it called? Math in the Morning. So, I'm gonna just have a couple of slides today. Feeling a little, I guess, less sure of myself or something. But it's Friday, so I try to get a little bit done today. I feel like yesterday I got a lot done, so I got actually this week I feel like I got a lot done, and I think it's really motivating to tell everybody about my slides if anybody's listening. So I was gonna bring up some slides. I'm kind of like still not getting into the super compact stuff, but next week we'll get into that, and also the measurable, the measurable. I mean, maybe I'll take a lot. Sometimes like I might take a really long time on just one slide. Like I might take a really long time making just that one slide for the measurable case, because then like if it's only for like 1 minute that I put it up, but it like took a while to make, that's great. That's a good outcome. So I want to do that, but I really have to think about it. Okay, so today I just had a couple slides. One was I think I got myself kind of thinking about this too much, but the first one is, you could put the slide up, Erin. So the first one was like, someone might say, where did we use the GCH in that proof of killing inaccessible cardinals softly? So the GCH is good to have when we're doing Easton forcing, when we change the continuum. That's how that forcing works, is you start with the GCH. So hopefully that slides up now. I wanted to just say and mention, then I started confusing myself, but so it's easier if I kind of draw it, like if I drew it on a chalkboard. But so imagine the first thing I draw is that lambda there in the middle. So this lambda is not in C prime. It's a strong limit, but it's not a limit point of C, so it's not in C prime. Okay, and then now imagine I'm drawing that gamma next. That below lambda is this gamma. I don't know. I guess my brain's sort of lost today. This gamma. So this gamma is the greatest element of C below lambda. Okay, so it's not a limit point of C, so there's some greatest element of C below. Okay. So this gamma has a gamma plus, which, since lambda is like a limit point, this gamma plus is below lambda still. And so we know these blue lines are like that's the GCH pattern. So we know that lambda is going to be, the power set of lambda is going to be lambda plus in V of G and V of G of H. So it's good to know where that lambda is originally going, the power set. And so, okay, so gamma plus, now in the forcing, it's going to be forced to be delta plus, where delta is the next element of C past gamma plus. So lambda plus is going to get matched to delta plus, which is clearly above lambda. And that already violates that it's a strong limit, that lambda was a strong limit and no longer is a strong limit. But I just was getting a little worried about, like, when you do Easton forcing, you can't have, this shape. You can't have this kind of a shape where you have, let's say this is gamma plus, and this is lambda. I can't, like, right now, I just, okay, sorry, let me just do this. So this is lambda, and this is gamma plus. Okay, so you can't have, okay, if you have lambda, and then this is like, let's say gamma plus or whatever in a cardinal. So you can't have lambda go to, the power set of lambda is here, but the power set of gamma plus is up here. But you could have them meet up here. Oh, okay, that's fine. So let me look at that picture again. So I just think that when we did that forcing we probably have to think about like, you know, what does this lambda getting, what's the power set of this lambda, just so you don't like violate the rules of Easton's forcing. But I think that all works out just fine. And I showed like, you know, this lambda plus and this, I can't think today, you guys. Delta, this lambda plus and this delta could be the same. Okay. But as long as gamma plus, the power set of that is above lambda, then we should be fine. And I think that when we do the Easton forcing, you know, it's not going to work unless we follow those rules. So we'll have to follow those rules when we're doing. Okay, so that's just, so basically, why do we need the GCH? Because that's how you do Easton forcing. Because you need the GCH to do Easton forcing. Is the answer that, like, after I made this, I was like, yeah, that's really it. But also, it's good to know like where lambda. I guess we don't really need to know where the power set of lambda is going, because all we need is to be a strong limit, the power set of anything below you is still below you. So we're not so concerned about what's the power set of lambda. But of course we'd want to do the forcing so we don't violate the rules or whatever. Okay. The other thing I made was the main part of this show, the main part of this talk is about supercompact cardinals. So this is just a slide starting to get into supercompact cardinals. So an uncountable cardinal kappa is theta supercompact if it's the critical point of elementary embedding, non-trivial elementary embedding, J from B to M, M's transitive, and M theta is a subset of M, where theta's between kappa and J of kappa. And so the guy is saying, I fly above the rest, I start trends, just like immeasurable cardinals, and I can see too. So the supercompact cardinal has these glasses on. So the M theta subset of M means that if there's a sequence of length theta, any sequence of length theta with elements that are in M, that whole sequence is in M. And we could talk more about that. And I believe if it's measurable, it's already like kappa, supercompact. So we'll talk about that next week. So next week, I think that next week I should get done with the slides. I mean, I know the things I'm avoiding are really hard, and like that I need to make those slides. That might take a while. But if next week, that's kind of my goal. Like next week, I should be able to get the slides done-ish. We still have plenty of time, but that would be a nice goal, because I feel like I got done with all the stuff that's sort of the like extra stuff, and now we can do just a one or two slides of the proof for softly killing measurable cardinals. And then we'll get into the degrees of supercompact cardinals, which is the whole point of this. And then like a visual of the proof for killing softly supercompact cardinals. Degrees. Okay, and then kappa is supercompact if it's theta supercompact for every theta greater than kappa. Okay. Well, thanks for hanging out with this week with me, and listening to me sometimes not say anything. And so it's like so helpful. I think there would have been, if I didn't do this, I think there would have been a couple days this week I would have been like, I can just do it tomorrow. I've got over a month before this talk. So it's really helpful to get things done. And I have to admit that it's motivating if you know someone's going to be seeing your slides. So, and not just me. It's so much more fun this way. Okay, well, I hope you guys have a really great weekend, and I'm sure I'll be really happy to be back here on Monday, and I hope you have a good weekend, and I don't know what I'm going to be doing, but it's pretty nice out, so I'll probably be walking around, maybe get a Maritosi again. Here comes Mr. Zeke. Here he comes. Here he comes. Okay, bye. We'll see you guys later. Have a good one.